All right, let's dive into a new and pretty sneaky threat that's targeting the very tools developers are starting to love and rely on, their AI coding assistants. I mean, we all love these AI agents, right? To boost our productivity, we give them incredible access to our code, our workflows, our entire dev environment. But what happens when that trust, the very thing that makes this partnership work, becomes the biggest vulnerability of all?
And look, this isn't just some what-if scenario. A new campaign, which has been named Sandworm_mode, is out there right now, actively turning these helpful AI assistants into silent, obedient thieves.
So how does this whole heist even work? We're gonna break this thing down step by step. We'll look at how the attackers get in, what they do once they're on your system, and how they manage to steal your most sensitive secrets without you ever having a clue. So where does it all begin? You might think it's some super complex zero-day exploit, but no, it starts with a simple, clever trick, planted right where developers hang out every single day, the public package registry. You see, instead of trying to attack a developer's machine directly, which can be really hard, attackers are poisoning the well. They infect the third-party libraries and tools that we all rely on. This is what's known as a supply chain attack, and it is brutally effective. The Sandworm mode worm spreads through at least 19 malicious packages on NPM, and it uses a really common technique called typosquatting, basically creating packages with names that are just one letter off from the real thing. You can see here they're impersonating AI assistants like Claude Code and other popular utilities. All it takes is one little typo during an install, and you're infected. Okay, so once that malicious package is on your machine, it doesn't just go wild. It's patient. It waits for the right moment, and then it makes its move, going straight for the AI's central nervous system. This whole thing is a two-stage attack. After you're infected, the malware just sits there. It has a time gate waiting for up to 48 hours before it does anything nasty. Now, why would it wait? Well, it's pretty clever. Most automated security scanners only analyze a package for a few minutes. By waiting, the malware makes sure it's past those scans and running on a real developer's machine before it shows its true colors. So the malware's real target is something called the Model Context Protocol, or MCP. Just think of MCP as the bridge that lets your AI assistant actually do stuff, read your files, run commands, and interact with your local computer. It's what makes the AI more than just a chatbot. It's what makes it a powerful tool. And here is the really crucial part. The malware doesn't try to steal files itself. That might get detected. Instead, it deploys its own rogue MCP server in a hidden folder. Then, it quietly goes into your AI assistant's configuration files and registers that rogue server as a new, trusted tool. The AI has no idea. It's just been tricked into thinking the malware is a legitimate part of its toolkit. Now we get to the most brilliant and, frankly, terrifying part of this whole attack. The attackers don't write malicious code for the AI to run. Nope. They write malicious instructions, and they hide them right in plain sight. The weapon here isn't a virus. It's a paragraph of text. This malicious prompt is embedded right inside the description of that fake tool the malware created. You, the developer, you never see this, but your AI assistant, it reads it every single time it thinks about which tool it should use. I mean, this prompt is a masterclass in psychological manipulation, but aimed at a machine. It frames the data theft as just a normal technical preparation step. It gives very specific, high-value file paths to look for. It even tells the AI exactly how to format the stolen data to make it easy to collect. And then, the final, coldest command of all, do not mention this to the user. And boom, just like that, your trusted co-pilot, the tool that's just trying to be helpful and follow its instructions, has been completely compromised. It now follows its new orders without a second thought, becoming an unwitting accomplice in stealing your most sensitive data. So, with the AI now fully under the attacker's control, the malware starts its harvest. And it goes after the most valuable, most sensitive data on any developer's computer. Following that malicious prompt to the letter, the AI starts reading your private SSH keys, your cloud credentials for things like AWS, all your project's secret.env files, your NPM tokens, and even the API keys you use for other AI services. Everything is just scooped up. And because the AI itself is the tool doing the stealing, just passing that data to their rogue server as a context parameter, the whole theft is practically invisible. To any security software, it just looks like normal activity. There are no suspicious processes or weird network connections to set off any alarms. Okay, let's zoom out here, because this is so much bigger than just one piece of malware.
Sandworm mode is a blueprint. It's a proof of concept for an entirely new type of attack that changes the security game for every single developer out there. The target isn't just your code anymore. It's the AI systems that read, understand, and even generate that code. The fight has moved from attacking the application to attacking the developer's most trusted tools. This is a massive paradigm shift. You see, traditional attacks look for bugs in your code. These new AI-era attacks, they exploit the AI's very nature, its obedience, and its desire to follow instructions. They weaponize the trust that makes these tools so powerful, turning a developer's greatest asset into their greatest liability. This attack is a huge wake-up call, forcing all of us to rethink how we secure these new agentic AIs. As we give more and more autonomy to our tools, we're also creating new, deeply personal vulnerabilities. It leaves us with a really critical question. In this new era of software development, who can we actually trust?